Hey, hi, hello. Are you able to hear me? Mm, so, are you able to hear me? Can somebody say something, or should I wait? Okay, I'll wait for some 10 minutes and then let some people join. Hey, hello guys. Are you able to hear me? Bipin, we already did for week 11 last, no, not last week, this Wednesday or Tuesday, I guess. So today we'll do for 12th week.
Okay, sir.
Uh,
That
okay.
session is already recorded, right? Because I didn't attend any sessions.
Yeah,
I,
it's already on the YouTube. And I'll also say that all the solvent structure, uh, the PDF or the slides, whatever we are having.
okay, sir. Thank you.
Okay. So I'll start with the 12th week. So you can join on the uh, periodic. I guess you can start that. You can join it here in the join pd.com and then you can put this code. Is anyone joining or not? One student joined. Okay. So from the 12th week, all the questions will be pretty simple, mostly from the MLE and SEBI sets, because and the other lectures are totally, what you can say, theoretical, and it will prepare some question that will take a lot of time to solve that manually. So those are basically algorithms. So we have just chosen some questions from SEBI and maximum likelihood expectation. No, yeah. So using that, we need to find some, estimate some parameters. We have only two students. So anybody joining or not? Uh, okay. So okay, I'll start if you are not willing to join. Fine. Okay. So this is the first question. I guess this similar type of question is there in the graded also. So this is a pretty simple one. You can solve and you can just type in your answer. I'll wait for 1 or 2 minutes and then I'll solve that problem. And in the end, I'll take some questions that can be important for your exam. But that I'll solve it after solving this problem. So you can expect some problems from those questions, even from this slides also. So you can expect some problems from not exactly same, but almost similar type of problem you can expect. It's better to solve the problem. I'll wait for some 1 minute or 2 minutes and then I'll solve this one. Are you guys solving or not? So that I can just, if you're not solving, I can solve it directly and go.
Excuse me, sir.
Yeah.
So, in practice assignment week 11,
Okay.
so there is question number 4 and question number 10. So, question number 4 appears to be the wrong question. Like it is asking for 4 p.m. and answer has been given like in 4:30 p.m.
Okay. Wait for a second. I'll just go through that.
Okay, sir.
Week 11, right?
Yes, sir.
Week 11, practice assignment, right? Which question? Fourth question. So, what is the problem in this question? Yeah, Janvi, what's your name? So, what is the problem in this question?
So here it is in question. It is asking 4 p.m.
Hmm.
and the solution we have been given the PDF part 1. The answer is like in 4:30 p.m.
Okay, that is a typo. Like the concept you got right. So for that, if you are having a continuous uniformly distribution, so at some particular exact timing, the probability would be zero. So that's the main goal about this problem. So okay, I'll correct that in that solution part. But you got the point, right?
Yes,
Even if
sir.
that is
And
4:30 also, that's correct. Yeah,
so
and the
there is
next one.
question number 10 also. Is the
Uh,
question complete there?
yeah, this is a complete question. So this is a uniformly distributed. So you'll be having, so for the uniformly distribution, you generally have the mean value as a plus b by 2, right? So a plus b by 2 is equals to 15, and then this mean is the variance square. Variance also you have the formula b minus a ka whole square upon 12. That you can equate, and you have two equation, two variable. You can get the value of a and b. And after getting
Yes,
the
sir.
value of a and b, you can see what's the boundary you are getting a and b. And then on the basis of boundary, you can calculate the probability.
So if we get the boundary, how we are getting the boundary and what will be the function we will be using in finding the probability?
Okay, this is a uniformly distribution, right? So in the uniform distribution, whatever the boundary you will get, like for example, a you are, what is the value you are getting a and b? Okay, so if you have not calculated, if, like for example, I'm telling you, if you are getting a as 10 and b as 20, so this is a uniformly distribution. So uniformly distribution generally represents like this. Uh,
So for A, the value I've got is 7.5 and for B is also 7.5.
no, so you are doing some mistake. So if that is 7.5, it's not satisfying your first condition itself. 7.5 and plus 7.5 upon 2 would be 7.5, right? But here it should be 15. So the condition would be a plus, the first thing is a plus b by 2 should be equals to 15. And then the other condition is what? B minus a ka whole square upon 12 is equals to what's the value in given here. So now you are having two equations, two variables and two equations, right?
Yes,
If you
sir.
will solve, you will get the value of a and b, right?
Yes, sir.
And then after, if you are getting some a and b, like for example, you are getting a as 13 and some, for example, b you are getting as 19. So your distribution would be like this, right? So from 13 to 19, okay? And the value, the maximum, the amplitude would be what? The amplitude would be 1 upon b minus a, that is 6. And if you have to calculate the area, like for example, you have to calculate here for probability x greater than 17. So if you calculate the area greater than 17, so that means what? 2 is the width of this rectangle, and the height is 1 upon 6. So the area would be what? 1 upon 6 into 2. So 1
So
upon
how
6.
we are getting 1 upon 6 into?
This 1 upon 6 is what? 1 upon b minus a. This is 1
Okay.
upon 19 minus 13.
Okay, so and the 2 is 19 minus 17.
What?
So the 2 you have written, that is 19 minus
Yeah,
17.
yeah. Because you need to calculate this area, right? To get the
Yes, sir.
probability x greater than 17. So a and b you can check. I just took some random value, but you can calculate a and b from this equation, right?
Yes, sir. Okay, sir. Understood. Thank you, sir.
Okay. Okay. So this was a problem, and we got two responses. So one is less than 0.25, and the other is okay. I also don't know what's the answer for this problem. Okay, I'll solve this. So anybody else wants to try this? Or should I solve? Okay. So see, this problem you can solve. So you need to calculate what? You have to calculate probability x greater than alpha n. This is what you have to calculate, right? Hmm. So this here you can use this, right? Chebyshev inequality generally you can use x minus np you can write, and the same thing you can write it here. And for this should be less than equals to Chebyshev is what? Variance of x upon this square. So alpha n minus np ka whole square, right? So and variance of x should be what? Here this problem what's been given here. Okay, so let X be it's a binomial. So the variance should be what? So it should be NPQ, right? And then alpha n minus NP ka whole square. And all the values you already have. So NPQ upon n square alpha minus p ka whole square, right? So you have the value n you have been given, right? P you already have. Okay, yeah, P also you have. Q would be 1 minus P. So P, Q also you have. So alpha you already have. And what else you need? Alpha P you already have. And all the values you will put, will get the value, right? Is it fine? Did you get the point,
Yes,
right?
sir. Yes,
Okay.
it is.
So this is the next one. So you have this distribution, that is the form of, like, you have in the form of vector, where we have simply combined two normal distribution, and everything has been given. The mu or the mean value has been given 3 1, and the covariance matrix is also been given. So now you need to calculate the distribution of y1, and this type of problem you can expect in the final exam also. Not this much simpler, but a bit like complex one. Okay, this is a pretty simple one. You can directly answer without like even using pen or paper also. Okay, I'll wait for 30 seconds, and then so I got one answer as A. Okay, okay. Uh, Anybody else? Okay, so this is not that difficult. Like, for example, you need to calculate the distribution of y1. So if you need to calculate the distribution of y1, what do you need? So you just need the mean value or the expected value and the variance of that distribution, right? So what would be the mean for y1? So the mean for y1 would be what? So from this matrix, you can see that the mean for y1 is 3, right? And the mean for y2 is 1. So I need the mean for y1. So I got 3 as a mean for y1. And the other parameter that I need is variance, right? So what is the variance? The variance is what? So you already know in the covariance matrix. So the diagonal matrix will represent the covariance. Like, for example, so this 6 will represent the variance of x1 and x1, x and x, or what, y and y1 and y1. So this is simply the variance, right? So if we are having this covariance matrix, so this will represent the variance of us, y1 and y2, variance of y1 and y2. This will represent the variance of y1 and y2. That is simply the variance of y1, right? So 6 is the variance, right? So now we have the distribution as 3 comma 6 as the distribution for y1, because now you already have both the parameters, right? This is done. So similarly, you can find for the distribution of y2. So what's the distribution of y2? You can just, for y2 also, you can directly see. So the mean value is 1, and the expected value, the expected value is 1, and the variance is what, 13. So you can directly write 1 comma 13 is the distribution of y2. Okay, this is a bit good one. So now you need to calculate the distribution of z, where the z is a combination of y1 plus 3 of y2. So tell me what's the correct one from out of this. So you need to calculate for y1 plus 3 y2, right? And this is the matrix you already have. So you already know the values of, so like, for example, tell me the first, if you need to calculate the distribution of z, you need what? The expected value of z and the variance of z, right? So how will you calculate the expected value of Z here?
Expected value of Z will be mu of y1 plus 3 into mu of y2.
Yeah, correct. And how will you calculate the variance?
That I don't know.
Okay. So the mean you can calculate directly. The mean will be y1 plus 3 of y2. So the expectation can work anywhere, like the addition of expectation can work anywhere. But for the variance, you can't directly do. For the variance, you need to do something else. Okay. So you need to calculate the what. So this is the fourth problem, I guess. So third, oh yeah, fourth problem. And you need to calculate the distribution of z, and that is y1 plus 3 of y2, right? And for that, the expectation of z you need to calculate. The expectation of z you can directly calculate the expectation of y, or you can simply multiply this. So you can write this z as what? Z as ay, right? A is a simple matrix that represents 1, comma 3, and the mean, the matrix that represents the mu value you already have. That is what I guess that was uh, that was 3, comma 3 1, right? So this is a 3 1. So you can do it directly. So 3 plus 3. So you have expected value of z as 6, right? Now you have to calculate the variance of z. So you need to calculate variance of z. That means you need to calculate the variance of ay. How do you calculate that? You can calculate like as a a transpose. Simply what you generally do, a square y, you have to calculate, right? So you can do it like this. If you have the matrix A is what? A matrix was what? 1, comma 3. So 1, comma 3. Then you need to write the variance of y, covariance matrix of y, and then 1, comma 3. Okay. If you'll calculate this, you'll get the value of the variance of z. Okay. Any okay. So somebody has given the answer also. A. I guess A is the correct one. So you can calculate by this covariance matrix you already have. What is the covariance matrix? 6, 1, 113. Okay. So this you can write it here. 6, 1, 130. And then if you do, see, this is 1 cross 2, this 2 cross 2, this 2 cross 1. So you'll get one value, right? So this will get removed. This will, so 1 cross 1 you'll get. So you'll get exact value of variance of z, right? So the distribution of that will be what? So 6, comma, whatever the variance of z you'll get.
Sir,
Yeah.
sir, from where we are getting A matrix?
A matrix. Okay.
Yes.
So A, yeah. So I just wrote this Z as like this. Z I wrote. So if you will see this Y, right? I can write this in the form of 1, 3. Right?
Yes.
This I can write 1, 3. And Y1, Y2. I can write like this. If you'll multiply this, Y1 plus 3, Y2. Right? So this is how I just wrote.
Yeah, okay.
Oh. So now we'll move to the next question. And the fifth question is, yeah, this is the fifth one. We need to use the Chebyshev inequality to solve this. Suppose x is a non-negative random variable, that doesn't matter, but okay. X is a non-negative random variable with expectation 60 and a standard deviation as 5. So what can we say about the best upper bound for probability x greater than or equals to 7? We need to use Chebyshev. It's given here. So the last 4 weeks are the most important ones. Like for the final week, you can expect some 50% of the problems from this 4 weeks only. So this 11, 12 weeks are pretty simple. If you are able to solve, we can get a edge over other people. Okay. So you can, so Chevyshep is important for you. The concepts are very limited even in 12th week. In 11th week, that the concepts are abroad, but in 11th week, we are just briefly explained all the probability stuff. So the question won't be that difficult from those. So from 12th week, you can expect one question from MLE for sure and from the Chevyshep. And I'll discuss after this completion of the solve with us. I'll discuss some 3 4 problems. You can expect one problem from those itself, like the same one, almost the same one, but a bit variable and all a bit different. Did you solve this? Okay. So I just got, so one people is 0.25. I guess the answer would be 0.25. Yeah, so the one person who has gave 0.25 as the correct one. Correct. So do you want more time to solve or should I solve this? Yeah. So I'll solve this. So here it's been given here. The standard deviation has been given here. So the SC has been given as 5. That means the sigma square is 25. Right? And the expected value is what? 60. You need to calculate what the probability is that x is greater than equals to 70. Right? This we can write it in this form, probability of x minus 60 greater than equals to 10, right? This would be less than what? This would be less than expectation of this x is what? Expectation of x is, sorry, expectation I'm saying. We are using Chevyshep, right? So sigma square. So sigma square is 25 upon 10 ka square. This would be less than equals to 25 upon 100. That is less than equals to 0.25. Okay. So this then the next problem, this was a pretty simple. All those questions are pretty simple ones from the Chevyshep or MLE only. This is the question that here you need to use the Markov inequality to solve this. So shopkeeper sells LED. The expected demand of LED is 4 per week. Based on the given information, choose the correct option for the random variable x, denoting the number of LED sold in a week. Yeah. So this is pretty simple one. This is a simple Markov inequality. So you need to calculate the probability such that x is what? X is greater than equals to 10. And that is what? Expected value of x upon 10. Sorry, less than equals. So less than equals to expected value, expected number of LED that will sell is 10, 4, and that is equals to 0. The next one, this also you need to use the Markov's inequality only. The probability of getting tails while tossing an unfair coin is 0.4. Suppose that the coin is flipped 30 times. Find the upper bound using Markov's inequality for the probability that it lands on tail at least 20 times. Okay. So you need to calculate what probability such that the number of times landing tail should be greater than equals to 20, right? Because written here at least 20. So you need to calculate for greater than equals to 20. This is also pretty simple. You can just write, do not take more than 45 seconds to solve this. Okay. So what? Okay. Okay, I'll solve this problem. So the probability of getting tails while tossing an unfair coin. Okay, so the probability you already have 0.4. Suppose that it's point the number of, so the n here is 30, and now you need to calculate the upper bound using Markov's inequality. So here, the seventh problem, you need to calculate probability such that the x, the number of tails will be getting should be greater than equals to 20, right? This should be less than equals to expected value of x upon 20. And the expected value is what for the binomial, how generally write the expected value, that is n into p upon 20. So n here is what, n is at 30. And the probability of getting tail is 20. This 20. So you'll get around what, 12 upon 20. Right? Anybody is having any issue, you can ask. These are pretty simple one. I don't think so there won't be any issue. You already have done this earlier also. So yeah, so one guy gave the correct answer. Okay. So the next one is, yeah, this is the next one. This you have to calculate using Chebyshev, and this is also simple one. Just a simple thing you need to check. Like the basic Chebyshev inequality that generally you use. So the probability says that x is greater than mu plus k sigma and x is less than mu minus k sigma should be less than equals to 1 upon k square. That basic inequality you have to use here. Okay. So yeah, find this one. So you just need to calculate the value of k. Okay. And if you are able to calculate the value of k here, you can directly calculate the upper bound for this probability. Okay. So should I solve this one? Okay. So I'll try to solve this. So this is the eighth problem. So eighth problem. So normal distribution you already know. For the normal distribution, if we're having this plot, for example, this is the mean value. This is mu plus k sigma, and this is mu minus k sigma. Okay. So generally, you have the two equations for the Jacobian inequality. Okay. So the first equation is what? The probability such that x is greater than mu plus k sigma plus probability x less than mu minus k sigma is less than equals to 1 upon k square. Okay. The second equation is what? So if we are talking about this area, and this area, it should be greater than equals to 1 upon k square. So what is left here? Now we are left with probability such that x is between mu plus k sigma to mu minus k sigma. That would be greater than 1 minus 1 upon k square. Right? So this is the both equation that you should be aware of that. So here in this problem we need to use this equation. The first equation we have to use. Okay. So what we have to calculate here? So we have to calculate probability such that x is greater than what? At least 130. So greater than 130 plus probability such that x is less than 70. Right? This we are aware. So now you are aware that mu plus k sigma is equals to 130. Mu minus k sigma is what? 70. Right? So you have this equation, you already have the value of mu, right? So the value of mu you already have. Okay, so mu you don't have. You just have the number of times you have flipped the coin. Okay, that is also okay. So uh, you have what? So n you have been given here. N you have been given here. N is what? 200 times has been flipped. Number of times that lands on head. Okay. So how will you do from here? So you have two equations. So you can just put it like this. what is the value you can take it here?
So the coin is fair coin.
Yeah, the coin is fair, right? So the probability you already have, right?
Yes, sir.
So Q, okay. Then you can calculate the expected value also. The expected value is what? NP, right? You can calculate the sigma also. Sigma is what? Root of NPQ. So N is what? 200, right? 200 into 1 upon 4. So you have sigma is equal to root of 50. Fine. Now you have the mu also, you have the k. So or else you can, what you can do, you can just subtract this equation. So you'll be left with what? If you just subtract this equation, you'll be left with what? So 2k sigma equals to 60. K sigma equals to 30. You just need k here. So if you have k sigma equals to 30 and sigma you already have. So the k equals to what? 30 upon root of 50. Fine. Now you need to calculate what? Less than equals to 1 upon k square. So this probability would be less than equals to 1 upon k square. K value you already have. So the k is what? 50 upon 30 into 30. So you'll be left with what? That is equals to 5 upon 90, right? This is 1 upon 18. So 1 upon 18 will be the final value. Okay. So this is how we'll solve. So you have this both the equation. This is the first equation. Okay. For the Chebyshev, and this is the second equation for the Chebyshev. Okay. So here it has been given the number of times should be at least 130 and at most 70. Okay. So now you need to calculate the probability from the first equation itself. So you can see the probability x as that it's greater than 130. That is just we have compared the value, and if we have compared the value, we got mu plus k sigma as 130 and mu minus k sigma as 70. If you just subtract, you will be having k sigma equal to 30. You just need k here to calculate the sigma, and sigma you just need k to calculate the sigma. Sigma can be calculated as it has been mentioned by one of our friends. He told, like it's mentioned in the problem also, that this is a fair coin, so probability of getting head or tail is 1 upon 2. So sigma can be calculated. Sigma is simply the variance is simply the NPQ. So sigma can be calculated the under root of NPQ, and from here you got the sigma value. Then you can get the k, and then you can calculate the value of upper boundary. That is one for sigma square. Okay, I guess this is clear. I'll move to the next one. If you are having any doubt, you can ask. Okay, I'll move to the next part. And the next part is also the Chebyshev, but you have to use the other equation. Okay, here I just gave you the hint also. You have to use the other equation. I wrote two equations there, right? So the first equation we used in the earlier question. Here you have to use the other equation. First, tell me the value of k. If you are calculating, just first tell me the value of k. What's the value of k you'll get? It's been given at least 99%. So So with what you'll compare the 99% with what? Then you'll get the value of k. Even you without calculating also, if somebody is guessing also, you can guess the correct answer, I guess, from the question itself. Can somebody guess the answer without solving also? Can somebody say a plus b ka value without solving? Not the exact a and b, just a plus b ka value. Here I have shown you that this is what? This is the equation you'll get here also, right? If you'll just do the summation of this. So this is a here and this is b here. If you do the summation, a plus b would be what? 2 mu, right? So 2 mu would be what? 80 into 2, 160. Okay. Now tell me the value of a and b. Okay, I'll solve this. So I need to use the second equation that I've told you also. The probability such that this coming in some boundary should be greater than 1 minus 1 ka 1 minus 1 ka whole square. 1 minus 1 upon k square. Okay. So this is the ninth problem, second last problem. And this I've told you should be at least 99% been told. So greater than 1 minus 1 ka k square should be equals to 0.99, right? So if this is 0.99, this means 0.01 equals to 1 upon k square. K should be equals to 1, 10, right? Fine. So now mu we already have. Mu I told you what was the value of mu? This is 80, right? So now the boundary A would be what? Mu minus k sigma, and B is what? Mu plus k sigma. So this is what A is equals to 80 plus, 80 minus 10 into, what is the value of sigma given? Is sigma given or not? Okay, it's given. That is 6. So equals to 20. Similarly, B would be what? 80 plus 10 into 6 equals to 140. Right? So this is the ninth problem. So we'll move to the next or the last one. So this is the problem. Suppose that the lifetime of a light bulb is modeled by an exponential distribution with unknown parameter lambda. We test 5 bulbs and find that the lifetimes are 3, 4, 2, 5, 6 years respectively. What is the MLE, maximum likelihood estimate of lambda? What is the value of that? So you can expect the parent distribution from where we are getting the lifetime is exponential distribution. So first you need to calculate the parameter for or the lambda or the parameter for the exponential distribution. What's the basic formula for that? And if you are able to get the basic formula to calculate the estimated value of lambda for exponential distribution, you can just put the value 3, 4, 2, 5, 6, and you'll get the answer. So such problem you can expect in the exam also. Like for example, here it is for exponential. You can get for some normal distribution or for some other distribution. Like for uniform distribution you can get. So this type of problem should be aware. You should be aware how to solve this. I'll solve this problem. I'll wait for 2 minutes. If somebody will answer the question, it's fine. Otherwise, I'll solve the problem. So here you need to write the likelihood function, okay, and then take the log and calculate the value. So who has given this answer? 3 above 3, I guess around what? How did you calculate that? I guess you just added and then divided by 5. That's not the correct method. So this is not the correct method. Okay, I'll solve this problem. So for the exponential distribution, so this is for exponential distribution, how generally write the likelihood function? The likelihood function is what? Just need to write the value of probability at each point, right? So, for example, I am having n values I took from the family distribution, that is our exponential distribution. So that would be what? Lambda into e to the power minus lambda x1 multiplied with lambda e to the power minus lambda x2 into lambda e to the power minus lambda x3. So this is how generally you represent one exponential distribution, or you can say one data that you are getting from the exponential distribution, right? So this I just wrote for n distribution. So similarly, I just wrote for n distribution. Okay. So this is what equals to what? This is equals to lambda to the power n e to the power minus lambda bracket x1 plus x2 plus till xn, right? If I'm taking log on both sides, that will be equals to what? N log lambda minus lambda, this summation of xi, right? This is what we'll get. This you can maximize, you can just differentiate it, equate it to 0. If you'll do this, what's the value you'll get? N upon, you need to differentiate this with respect to lambda. You'll get this minus sigma of xi, right? That you need to equate it to 0. You'll be having what? N upon lambda equals to sigma of xi. What is the estimated value of lambda? So lambda you can write n upon sigma of xi, right? So this is the estimated value of lambda for the exponential distribution. So you can just remember this. You can expect some question from like this. So now you need to estimate the value of lambda. So you have the xi is got 3 plus 4. So lambda equals to 5 upon 3 plus 4 plus 2 plus 5 plus 6. This you can do. You will get the expected value of lambda. So this will be the answer. Okay. So like this you can calculate using the maximum likelihood estimator. Is this clear? This is the 10th question. Okay. So fine. So I'll just so this is fine, and I'll move to some other part. So where I'll just give you some problem like so this type of problem you can expect in the exam. So I just solved this type of problem in the last lecture also, but okay, I'll just discuss it again. This I'll discuss again in the revision session because these are all like all not the all the problems, but I'll just tell you one problem in the revision session also. But this type of problem you can expect, and if I'm telling you, you can expect means you'll get some problems like this on the basis of transformation, and then you need to calculate the joint distribution. So you have this distribution in the form joint distribution in the form of xy, and this is the distribution you have been given, and the transformation also you have been given, like u equals to 1 upon 2 x minus y and v equals to this. Yeah, now we need to calculate the joint distribution of ub. So how will you do this? Can somebody tell me how will you do this? We just discussed this in the last lecture also. Are you guys here or what? Like, I don't know what's the issue. Should I discuss this or close this?
Yes, sir. Please discuss.
But nobody is generally responding. How will you take the session if nobody generally replies? Very monotonous, like it's boring also. Okay, so I'll just go through the problem. So the first problem, we have been given the joint distribution in the form joint distribution of xy. So we have been given the distribution of xy, and the transformation also we have been given here. That is u equals to 1 upon 2 x minus y v equals to 1. So to solve this type of problem, we need to first calculate the first transform the x and y x and y in the form of ub. Okay, this is the first step you should do. So I'll just write the steps here. The first step is express x and y in terms of u and p. Okay, this is the first step you should do. So you have the transformation. Express x and y in terms of uv. The second step is compute the Jacobian for that matrix that you have got. So compute the Jacobian. Okay. And then the third step is pretty simple. You can just write fx, sorry, the joint distribution of GUB equals to fxy into Jacobian distribution. And the fourth step would be to calculate the we can write this as a third step. So what you can do, you can calculate the domain. U and V, okay, from given X and Y, right? Now you can write the joint distribution in VUV equals to fxy multiplied with the Jacobian. And if you have been later asked to calculate the distribution of this, if you have been asked to calculate the distribution of 1/2 x minus y, then what is this? This is simply the marginal distribution of u. So you need to calculate now. If you have been asked to calculate directly, so it's the transformation is not been given. If you have been just asked to calculate the distribution of this u, so you can just take a transformation from your side. Like for example, this b equals to y. You can take this and calculate the joint distribution of uv. Okay, and if you have the joint distribution of uv, then you can calculate the distribution of you can calculate the marginal distribution of u, because now you have the domain also, because you already have calculated the domain. So everything you have you can calculate, right? Okay. So for this problem, I'll just solve for this problem, and I just gave you 4 or 5 problems, so you can just solve this. I'll just share this PDF with you. Okay. So the first
Sir, where
question.
are you going to share this?
Okay, I'll share with you on the Discord. Okay.
Okay,
just-
okay.
Okay, I'll just upload it on some Google Drive and then share the link in the Discord. Okay.
Yes, sir.
So here you need to calculate. The first step is what you need to express xy in term of uv. So how will you do this? So you have u equals to 1/2 x minus y, and you have v equals to y, right? So how will you express? So y equals to v. Simply you can write x also equals to 2u.
Sir, are you writing something? It is not visible on the screen.
Not visible.
Whatever you are writing,
Not
yeah,
visible.
now it is visible. Yeah.
Been shared for me. Like, I don't know. Maybe from your side there was an internet issue.
Yes, sir. Maybe.
Okay. So this 2u plus v. Okay. So now you can calculate the first step. You've done the first step. Then second step is to calculate the Jacobian. So you can calculate the Jacobian. How generally you calculate the Jacobian? Dx by du, dy by du, dx by dv, and dy by dv. So you can calculate the Jacobian here. So it's what is this? This 2, right? And then you need to differentiate with respect to this is 0, this is 1, this is 1. So the Jacobian is 2, right? So you can directly write now. So GUV you can write, right? This is equals to 2/alpha square. And in spite of this x and y, you need to write UV, right? So if you write UV, you'll get e to the power minus 2u plus 2v upon alpha, right? So you got this equation. Now you need to calculate the domain. So how will you calculate the domain? So now to calculate the domain, so xy is greater than y, xy is greater than 0. Okay. So here the first case is what? Xy was greater than 0, right? So v is directly, so x is what? X is what? 2u plus v greater than 0 and v greater than 0. Right? So v is greater than minus 2u. So you can write this equation. You can write directly.
Sir, won't
But
it be 2u plus v there instead of
where?
2u plus 2v in that GUV?
Okay, here.
Huh?
Okay, so x for x is it's 2u plus v and 1
Okay,
v.
yeah.
So you can directly write it here. V greater than 0, v greater than minus 2u. Okay, and u will vary from minus infinity to infinity. This from minus infinity to infinity. This is the, and for other cases 0. So this is your joint distribution. For UV. Okay. And similarly, you can do for the other problems also. Like here it is, one problem has been given. The second problem is what you have been given: the joint distribution of x1, x2, and x1, x2 lie from 0 to infinity, and the transformation given here. Okay. So transformation is given like this. Okay. And then you need to calculate the joint distribution of UV. Do you want to calculate this? You can calculate. So first tell me the Jacobian for this. So first, the first step is what? To transform, to express x1, x2 in the form of UV. To do that, then calculate the Jacobian and tell me the Jacobian value. Okay, I'll solve this. I don't think so anybody is solving. If you write x1 next to in form of UV, so x1 you can write it like this, u by 2. x2 you can write,
V plus u by 2.
yeah, v plus u by 2. And then if you are calculating the Jacobian, tell me the value of the Jacobian. What is the value here?
1 by 2.
1 upon 2.
1 upon 2.
1 upon 2.
0, 0,
0,
1.
1. So Jacobian value you are getting is 1 upon 2, right? So now you can directly write this GUV as fxy into 1 upon 2. And this you can write it like this. What is this? 2 e to the power minus of xy, if you will put it here, u plus p into half. So the domain I need to fix. So the domain is what? Domain is, the first equation is what? X1, x2, both are lying from x1, x2, lying from minus infinity to 0. This is what has been. So x1 is what? X1 is u upon 2. X2 is what? V plus u upon 2 minus infinity. That you need to solve and get the value of u and v. Some ranges, okay, you will get. This is how you will solve for the fifth problem. Okay.
Yes, sir.
Similarly, yeah. So similarly for this problem, so all the problems are almost similar type, and this I've just took 4-5 examples so that you get the idea. So if you are getting some problems like this in the exam, it will not be blank directly. Okay. So you can solve the problem at least. And if you're getting some problem from this transformation, so you can expect like if one question has been given, so it will be having some 3-4 subparts. So if you're able to solve even this problem, only this problem, you'll be able to get some 6-7 marks out of only one problem. So it will be like in some subparts. So this time there will be some question that will be in the subpart, like 2, 3. So that if somebody is losing the marks, is not losing whole marks. Okay. So that's the purpose of just
So the
solving
number
test.
of questions will be more and the
Yeah,
weightage less per question. Is it?
yeah.
Yes, sir. Actually, that is better.
So that's why like we tried this one, because earlier like if even one question was some typos error was happening, so we were able to like give some 8. So last time we gave some 8 marks, right? And this would be better like last session somebody is saying also, if we are giving a
Yes, sir. There,
problem.
even if one step goes wrong, then the
Yeah,
entire, yeah.
correct. So even if we are able to not solve the final answer, if you are not getting, you'll be able to solve some steps, right? And if you are able to solve some steps, there would be some subparts 1 or 2 that you can answer and you can get the value. Right? So you'll not lose the whole mark. If you are not able to solve the completely, you lose some marks, right? So simply for this problem also you can do in the same way. The first is what you need to calculate, express x1 and x2. So the x2 is v, and the x1 you can write it directly uv. Okay, and x1 x2 you have. Now you can calculate the Jacobian. The Jacobian is what you'll get v here, you'll get u here, you'll get 0 here, you'll get 1, right? So even if you are doing, see, if you are interchanging this both the two, if you are somehow forgetting the equation, forgetting the equation in this Jacobian, if you are writing dx by dv here and dy by du here, so it's not like there won't be any change in the final answer. Okay, so the Jacobian is v for us, right? Now if you need to write the joint distribution of uv, you can write it like this: f of x comma y into Jacobian. That Jacobian is what v here. So you can write it here 8uv into v, and this Jacobian is v. So you'll be having 8uv3, right? So this is now you need to calculate the domain. So I'll calculate the domain. So here this x1 x2 is less than, so you'll be having 0. So the value of x1 is uv less than v less than 1. From here you need to get the value of uv. So you get the domain here. This is how you'll solve the third problem. And this is the last one. This is also same. The transformation is, and one more thing, if you have been asked to calculate, like for example, if you have been asked to calculate the distribution of u. So distribution is u is what? This is simply marginal distribution of u, right? And how will you do this? You just have to fix the value of u and integrate it for v, right? This is how you generally calculate.
So
Right?
firstly, we will calculate the joint distribution and then integrate over the range of v. Is it?
Yeah. So if you have been, so for example, if you have been given this equation, joint distribution, and you have been asked to calculate the distribution of x plus y, okay? And if transformation has been given, like u equals to x plus y and v equals to x. So this is how you'll do. First, you need to calculate the joint distribution. Joint distribution of what? Joint distribution of, you need to calculate the joint distribution of this GUV you have to calculate, right? So how will you do this? So you can write in the form of xy. The same step you need to, so x equals to v, y equals to u minus v, right? And then you need to calculate the Jacobian. The Jacobian will be what? 1, sorry, 0, 1, 1, minus 1. And this is minus 1. Okay. So you can write the GUV as fxy into Jacobian. And you need to take the mod value. So this is similar to fxy, right? Only you need to replace the value of xy. This is x is v, and then e to the power minus u minus v, right? And the domain you need to fix. The domain is what? X is less than 2 less than 0. So the v would be what? 0 to 2. Simply you can do for the y also. Y is greater than 0. So u is greater than v, right? This is the domain you got, this and this, and 0 for all other cases, right? Now, if you have been asked to calculate the distribution of x plus y, so the distribution of x plus y is what? Simply, you need to calculate the fb. What is this? Fx plus y. Fx plus y is what? You need to calculate. How will you do this? So whatever you have, so you can calculate like this. This you have to calculate this GU calculate. So GUV have been given, right? And you need to fix the value of fix this u and integrate it for v, right? This is how you get the marginal distribution for x plus y or u, right? This is how you have to solve the problem. Okay, so I'll just upload this whole PDF. You can just check the steps and can try to solve some other problems also. But this is more than sufficient. If you are able to do this 4 only, you'll be able to solve the problem in the exam also. Okay.
Yes, sir.
Yes.
Sir, in the constraint optimization part, what can we expect, sir? There is stochastic gradient descent also. Such concepts are there.
Okay. So in that last, okay. So I'll discuss that in the revision session. But if you want to know now, I'll just tell you in the week, like that is in the week, which week? 9.
10, 10.
So it starts with week 8, right? Week 8, you have to solve the problem. You have to, so in the week 8, you just solve the, you need to know regarding the objective function. And without constant, you have to solve, right? I guess in week 8, been given. Week 9 is like objective function plus some constant is been given. And the gradient descent also is there. Gradient descent is there starting from here, but the projected gradient descent has been talked there. And then week 10 you have been solved. So week 10 is like the convex function and then the KQT conditions and all. So what you can expect in the final exam will be, so the most important thing is if you are given some conditions, so you should be able to write the objective function plus the constant. Okay, so you'll get some sort of problems where some conditions or the paragraph will be given. You need to find the objective function and constant. And always aware of that, we have been dealing with the constant, only one constant here. But there can be some problems where there can be more than one constant, right? It depends on the condition what has been given in the question. Okay, like for example, if we have been asked to calculate something like the selling price of some, you need to like for example, a factory is there and that factory is producing, like for example, some number of LED TV or some number of smartphones and all. So if that x is a variable for them, so x must be greater than equals to 0, right? Because x can't be less than 0. So if you have been given some options where the x is greater than equals to 0 in some constant, you need to take those options also, because x can't be negative, right? So you can have more than one constant for one condition, right? So that is the important thing that you should be aware of that. But rest of the like so gradient descent and all, these are like most of the theoretical part. You should not like, I don't think so there will be much questions from the gradient descent. I don't think any questions will be you can prepare from the gradient descent. There can be theoretical questions, but I guess most of the problem that we have in the final exam are mostly mathematical based. Okay, so from gradient descent and all, those are basic important concept that you should be aware of that. But to prepare the question, I don't think so there can be much questions from the gradient descent. Rest I'll deal in the revision session. So I'll come with some problems that resembles the final. And also, has the mock been uploaded?
No, sir.
Okay.
No, sir, not
So-
yet.
Okay, so it will be updated by today or tomorrow after you submit everything. So the mock will be updated. So I'll tell you the mock also which problem are the important one. And now in the revision session, I'll come with some problems and we'll deal with the problems. And that would be an important one. You can expect similar type of questions. So last time also I did, and I guess many of the question has same like the similar pattern. So this time also we'll do in the revision session, we'll come with some problems, 50-20 problems. And if you're aware of those problems, you will be able to score good, or you'll be able to like I'll deal all the important topics itself, from where we can expect some problems and from where we can have some problems, right? So we'll deal with that in the revision session. So we'll have the revision session, I guess one is from week 1 to 4. I guess that is on this Friday. And then the rest two, one is from 5 to 8 and then the 9 to 12. So in this both the session I'll be there. So in the last session I'll be dealing with the problems. In most, like in all the 3 sessions, we'll be dealing with the concepts and then the problems. And then most of the problem will be dealing in the final session. That will happen before the exam, like 3-4 days before the exam. Okay, so this 3 will be that's our plan for the revision session. So for the mock, it will be updated by today. Yesterday only, like I thought it was updated, but okay, it will be updated by today or tomorrow. So you'll get the announcement regarding that, and we'll announce you regarding the marking scheme also. But already I told you, like from last 9 to 12, you'll get some 50% of the questions, and the rest you'll get from 1 to 8. Okay, so this is how your preparation should go. So you should give more weightage to last 4 or 5 weeks, because those problem has not been asked in any of the quiz. So that's why the weightage will be high for this. Okay. So I'll come with the revision session. I'll deal with all the problems there. Is that fine?
Yes, and
Yes,
those
sir.
will be starting from this Friday, right? Next
Yeah.
week.
Yeah. Next week, Friday, or that also I need to finalize the timing. And so most probably it would be on Friday 7 to 9, but I'm not sure because that has not been reflected on the calendar. So that I need to ask whether is there any vacant like slot there or not. So 1 in this week and the rest 2 will be in the next week. Okay.
Okay, sir.
Okay. So I'll share this, and the solution also I'll share. You can just go through this solve it as solution, I guess it's fine. So I'll just upload it on the portal itself on one Google Drive, and then I'll share in the Discord. Okay.
Okay, sir.
Okay. So I'll just stop the sharing now. If you have any doubt, you can ask. Or else, if you have not any doubt, we'll meet in the revision session. So please do come there. So we'll solve some problems that might help
Sir,
you in the
can you
final
discuss
exam.
the KKT conditions?
So
That part
KKT,
is
okay. So those parts will be discussed by the Ram only. So he'll be the person person to deal those weeks. Like I guess 10th week is there, right? The KKT condition. So Ram only deal with those problems. Maybe the next week, next Friday he'll become not next Friday. After that, so I'll tell. Okay, so KKT can so next week I guess you don't have the you have the session I guess on the Friday. Okay,
sir, Mondays we have session, right? Mondays
no,
there is some
Monday you
session.
don't have. Friday, Wednesday it's there, but it will not happen. I guess it will happen on the Friday itself. So okay, so that one thing can be done. There can be one session regarding the mock to solve, and in those problems, I'll ask Ram to discuss the KKT again. Is that fine? Because he is the best person to deal with that
Yeah,
concept.
okay, okay.
Okay. Okay. Anything else?
No, sir. Fine.
Okay, so we'll meet in the next week. So I'll schedule that and we'll get the announcement regarding the revision session. Please do attend the revision session. Okay. Thank you everyone.
Thank you, sir.
Thank you, sir.
Okay, thank you, Pras. Thank you.